My research is largely grounded in the science of natural hazards. And by natural hazards, I mean processes that operate on the surface of the Earth or at shallow depths in the crust of the Earth. For example, earthquakes, on the surface, tsunami, landslides, floods, a wide spectrum of natural hazards. Canada has the full set, if you will, of hazardous processes, so you can just walk through them: earthquakes, tsunami, landslides, floods, even hurricanes. The Atlantic seaboard is impacted occasionally by hurricanes that come up the Gulf Coast from the U.S. So we have it all. Vancouver and Victoria have never been damaged by an earthquake, but we know we get earthquakes in that region. So there's a lot of effort being made into getting ready for what we feel is an inevitable earthquake on the West Coast. A very large earthquake in Vancouver could cause more than $100 billion damage, which is more than just a local problem, that's a national problem. We know a lot more about earthquakes than we did 10 years ago. We have technologies in place that allow us to kind of take the pulse of the Earth, to see how the Earth is deforming and getting ready for an earthquake. And our knowledge, improvement knowledge, which is largely funded through government support, allows us to provide better guidelines for engineers in constructing structures. So in Canada we have what's called a National Building Code, and that has within it what are called seismic provisions that our engineers, contractors must follow when they build public structure, infrastructure. And there's this process by which scientific knowledge gets incorporated into the building code through those seismic provisions. And as a result, and through improvements in engineering technology, our modern buildings are much, much better able to withstand, say, the forces during an earthquake than a building that was built even 30 years ago. The technologies that we now can use, the GIS technologies, the high-precision GPS technologies, satellite-based technologies that allow us to detect changes on the Earth's surface of millimeters per year, that in a sense give us a snapshot of how the surface of the Earth is deforming due to the processes that are operating at depth. And it's our ultimate objective that this will give us this pattern of deformation, which we can monitor continuously, you know, it's a continuous monitoring process, will give us some clues as to when an earthquake is imminent. My great goal is to raise public awareness of these issues and to play a part in driving public policy change. One person can do that, but as a collective, scientists can have an impact on policy.